I'm Julian. Some of you might know me already. Some might know me from the stimulus reflex and keyword ready projects, but I'm gonna talk about that today. Gonna talk about organizing business logic with DCI in Rails.
What's DCI?
Yeah, I was gonna say the aficionados of British crime series translated that already as Detective Chief Inspector. Of course, and well, as a teaser, Batman will make an appearance in my talk. And I always say this is I'm really not an expert in this stuff as well. It's just me being a fellow explorer, sharing my experiences with some of more exotic patterns, if you like. So Ruby on Rails did a lot to avoid any byte shedding by promoting convention over configuration, et cetera, et cetera. We all know that. There's still one area that always like sparks debate among Rubyists, and that is where to put the business logic. In other words, the code that epitomizes what an app actually does. Another way to phrase this question is where the ... do we put all the transactional code? And there's mainly these two poles. The one is the sort of golden path that's obviously endorsed by 37 Signals and consultancies like ThoughtBot. And I think I heard it somewhere that that's mostly what GitHub does already. And on the other side, we have domain-driven design, which is favored by Shopify, obviously, at least they say so on the developer blog, and the guys from Arkansas for consultancy also favor that. Which one is for you? I'm gonna go into that because that largely depends on how large your app is, how many business domains it touches, on the infrastructure requirements you have, et cetera, et cetera. What I want to do is just first take a closer look at some of the popular alternatives and the pros and cons. And the first one is something that probably everybody knows. That's the fat model pattern or whatever. This code snippet is from Jorge Manrubia's Vanilla Rails is Plenty blog post, if anyone knows it. I'm gonna put all the references somewhere later. Basically, fat models are models that are equipped with some kind of methods for processing the data, possibly including side effects, possibly reaching out to other models like we see here. Like this recording class has a copy-to model that allows to sort of copy itself to a destination bucket, etc. It's obviously Basecamp code. But there's some sneaky problems and code smells that can occur if you do that. The one that's most prominent is probably feature envy. So if you do this, models reaching out to other models to query their internals or to mutate them or create other models, etc., to me, at least, are kind of a red flag. Because it introduces coupling, and we don't want coupling. At least I don't want coupling. Models or objects in general should be confident sending messages to other models and should not be concerned with what they do with that, et cetera, et cetera. There's also a bit of a smell of a single responsibility principle violation here, because if you ask yourself, I'm adding this code to a model, is this really something that the recording should be concerned with? Like, Should the recording itself be responsible for copying itself? Does that sound right? To me, at least, not quite. Often these kind of fat models have a logic living in callbacks. Now that's a controversial topic for sure. I'm not gonna go into any depth here, but it can be a powerful tool, model callbacks. They can also hide complexity and behavior in sort of weird spots where you don't find it. And if you have bugs with them, they're hard to find. Absolute red flag are like sending emails from model callbacks, because the second you like access it from a Rails console, you accidentally send out 1 million emails. It's always a good thing to do. So my rule of thumb, I'm gonna share that with you. My rule of thumb is to, with model callbacks, is to allow them to pre-process self or post-process something about themselves, but never actually do any side effects or trigger jobs or something like that. And fat models have the tendency towards God objects. I mean, give it a few development cycles, and those attract functionality like honey attracts bears. Like you're gonna have dozens of methods attached to them, and I want to bring in the perspective of Jim Gay, which is largely, I'm paraphrasing him actually in this talk a bit, with his Clean Ruby book. Is the perspective from inside a model actually the best vantage point to design what the app does? I say no. And this is something that more recently also sparked something else, and that's the service object pattern. Like, I don't know, 5 years ago, everybody was all about service objects. And if you rewrite this as a service object, what's really a command pattern instantiation, we would probably write something like this. Service object record copier, and we call it with the source and the destination. So yeah, we pulled this side effect out of the model. And cool, right? This is from Chase Sweat. There are a couple of problematic facets with this, but I'm gonna just tell you the focal point of it, and that's this object, that one, does not encapsulate any instance state. It just calls itself, it's called and it's forgotten afterwards. And at least for me, this is a sign that this doesn't actually describe any concept of our domain. And it also kind of runs counter to the accepted practices of describing your domain with nouns and the messages you send to those objects with verbs, right? So classes that are named using a normalization of a verb, such as record copier, are actually indicated that you identified a correct message, but you couldn't come up with a receiver. And that can be really a pain to refactor afterwards. But first and foremost, I was always like a bit confused by this paradigm and this pattern, because Rails already has a built-in primitive for this. It's a job. So if you rewrite this as a job, we actually only have to swap out a few method names and inheritance, etc. And it's actually looks the same, right? Well, not quite. Because jobs have their own limitations and requirements, and they can be quite daunting. And the one that's the most problematic here is idempotency, because most job processors make no guarantees that jobs actually run only one time. So if accidentally this job is run 2 times, you have 2 copies. And you don't want that. So you have to take additional precautions in case this is ever run twice. There are There are gems like the acidic job gem, and there are Sidekick Pro and Enterprise have some mitigations for this kind of thing, but you don't always have access to them, and you actually don't want the overhead of thinking about that stuff. And the other thing is that jobs can't return a value. Now that might not even be a bad thing, but also you don't really know in general if and when they are finished. You can come around that using job callbacks, et cetera, et cetera. But yeah, also not really perfect. And then there's event sourcing. And I only added this here for sake of completeness because the guys from Arkansas, et cetera, rely heavily on that. And Martin Fowler describes it as event sourcing ensures that all changes to application state are stored as a sequence of events, paper trail. Can we query these events? We can also use the event log to reconstruct any past state. Has anyone ever had the joy of working with Redux, React Redux? That's essentially what Redux does. And it's not a bad pattern at all, because it can be perfect to construct a versioning system of some sort. So if you write the next Git successor or something like that, it's what you want to do. Personally, I have no experience at all with that, so I just put it up here for completeness. And that's it for the popular alternatives. And then here we come to DCI, and I'm gonna only read this once. The second time I read something from a slide. The paradigm uses separates the domain model data from use cases, the context, and roles that objects play. DCI is complementary to model view controller. It was even invented by the same person. So MVC is a pattern language is still used to separate the data and its processing from the presentation. That's what makes it so useful in my view. It's also a code architecture style that simultaneously, as we shall see, lets us consider the application as a whole, while at the same time not introducing any objects with unclear responsibilities, such as a record copier or something. It also is designed to improve our understanding of system-level state, what a system is, versus system-level behavior, what the system does, by putting those two concerns into different modules. Slowly changing domain knowledge. If you think of how often do you add something to a model, how often do you run DB migrations, etc., changes not so often. And what changes more rapidly, of course, are the features, is the business logic, everything that the system does. I'm gonna start breaking this down into the individual parts. So if we start with data. By the way, this is what Stable Diffusion thinks data is. So if you prompt it just for data, you get that. I found that pretty cool, actually. So this is the typical example of DCI. You have a bank account, and the bank account has a balance, and you have two methods: increase it by something and decrease the balance by something. That's what the system is. It explicitly lacks any functionality that involves communicating with another object, i.e. it's completely devoid of any business logic. So now everybody knows his Martin Fowler by heart, I assume. So we all know that this is an anemic model, and that's probably the most terrific, the most terrible anti-pattern of all time. Martin Fowler says so. I mean, and what does Batman have to do with it? And just hear me out for a second. The point is not from DCI's perspective to rip all the domain logic from the models. It just says that we should dynamically attach it when we need it, carry it off afterwards. And that is what a context in DCI is. Now, I know we have some Elixir savvy folks here. So if you look to Phoenix, you have something like a context there, and it's a completely different thing, but they have Phoenix context and what I'm going to talk about have something in common, and that's they separate the type definition from the behavior. And if you think about it, the nice thing is about a context is that it's they align nicely with our mental models of everyday processes, because we as people also don't assume or carry around with us every role that we play at any time. So if we are at school, for example, some have the role of students, some one or more have the role of teachers. In a public transport at the right, some are passengers, others are conductors, etc., etc. Some even play multiple roles at once, and they may change over time. So if I step into the U3 afterwards, I'm a passenger. If I'm very bored, I might become a book reader. If somebody calls me on the phone, I'm a participant in the conversation. In the case that I travel with my daughter, I'm also a parent and I have other responsibilities. And that's exactly actually what the concept, the definition of a role is. It's one or more responsibilities. So if you look at this very, very small module, it's only one method, transfer money to destination amount, blah, blah, blah. And the important thing, as we shall see in a second, is the reference to self here. It calls self, decrease myself by an amount, and increase the destination by the same amount. And of course, we wrap that in transactions, etc. Left that out. The beauty of this pattern in Ruby is that Ruby allows us to inject modules at runtime. So the context might look like this. I initialize a transfer class with a source. And at the moment I initialize it, I also include this money transferring module and delegate the transfer money to method to the source. This is leaving out some boilerplate, etc., but just to get the point across. At this very second, I have mapped two roles. I have mapped the source to one bank account, and I have mapped the destination to another bank account. And I put this in there because I wanted to memorize something, and that's the two guys sliding down the bedpoles. The moment they flip this instant costume change lever, our modules take on two different capes, one for the source account, one for the destination account. And when they finish their job of arresting Joker or whatever, they can put off the capes and be done with it. So the final part of this pattern is called interaction, and that describes what the system does by assuming a perspective of being among them, not within one of them. So this is how you would invoke that. You would create a transfer object. You would then, with a source, and you could invoke the transfer money to on that object. This is simple as it can get, but I want to point out some peculiarities. So these bindings, the transfer money to being bound to the transfer object, etc., are guaranteed to be there only at runtime. So afterwards, this transfer object is going to be picked up by the garbage collector, and the source and destination accounts are going to forget everything they know about each other. Why should they? And if you think about it, you can flip this around, because it means that these DCI roles are absolutely generic, which makes them both easier to reason about and easier to test, because the transfer context makes no assumptions whatsoever about the roles that are being mapped to it, other than that it needs to have an increase and a decrease method, and that's for us to implement. In other words, the fact that those are bank accounts is completely irrelevant to the transfer context. Those could be wallets, stock portfolios, money boxes, whatever. The context is completely unaware of what it deals with. We have achieved low coupling. And it's only through the enactment in a certain use case that they are associated with certain types. And if you look at that snippet, it's very, to me at least, it's very succinct. It's clear what's being done here, and readable. And I'm going to end this talk with a short case study, because so far we haven't seen any Rails code, other than bad one. With a little case study from an app of mine, which is a context wrapping essentially a Stripe checkout. So the role payable is taken from Jim Gay's surrounded gem, which basically just strips away some of the boilerplate. So you can think of that as being this kind of wrapper and the include of some module just in this class method. This create session method only relies on self. It relies on a global ID being present, which is true for every active record object, and on an accessor named line items. So it's only dependent on stuff that's being brought by the payable, whoever assumes the payable role. So with that, we can write a test. How do we do that, right? That's pretty easy, actually. I omitted, obviously, some of the stubbing stuff here. We can write a test that is asserts in this very simple case that on fulfillment we get the correct record back, etc., etc. But the point is, we could just as well insert something else than a quote, as we will see in a second. Because in my app, this serves two use cases. The one is a quote. So a quote is something, a very bespoke agreement I make with a client. Usually only has one line item, because most of the time it's a very small thing, just one to do, something like that. So my model defines line items, which stem from a Stripe price I created somewhere. The controller will create this Stripe session, Stripe checkout session. And in the view, we just grab the URL and open the window. Cool. Use case 2 is my larger productized service, a review. And a review has several chapters, and each of those chapters has its own Stripe price ID. So I map the line items to those Stripe prices, and the rest is the same. We create a new checkout with another payable. This time is a review. I get a Stripe checkout URL, etc., etc. If anybody is wondering, the shameless plug, where this comes from, it's from my productized service called basereviews.com. I have stickers. Anyways, I've bored you long enough just to come to an end here. It's certainly not a grab-all solution to all problems with code organization, but to me at least, it feels like a natural inhabitant of a Rails app's system. It comes up with a clear structure to separate the descriptive structuring of what an app is via the models from the behavior, without compromising the solid principles, which at least in my experience allows for very easy refactoring. The design of business logic itself feels more streamlined because it attempts to reflect the mental models we construct when we build the software more closely. But there's also cons, of course. You might find that the separation of behavior from data is something that diminishes code cohesion. You have to sort of look up more stuff in your code base. If you want to try it out for size, I would recommend stuff that's actually fringe to your app. Because why do I say that? Because typically those areas of like interfacing with a third-party API, like Stripe, or like, I don't know, in my case, it's for some SavvyCal and others. Typically, they don't change that often and are a good place to start experimenting with new tools. So, last slide, references. Large parts of this considerations were more or less paraphrasing Jim Gay's Clean Ruby book, which is a bit dated, but still was like really an epiphany for me. And also his Surrounded gem, which, as I said, just strips a bit of this the boilerplate away when you deal with DCI. Thank you.